Hey, folks. So today's topic is climate change. Now, in our readings for this section, there's a focus on the diplomacy and international negotiations that surround climate change, including the Paris Accords. But and there's also a comparison to the ozone um, layer problem and how the international diplomacy dealt with that. So it's kind of an interesting to compare and contrast these cases. Um, in lecture, I'd like to focus a little bit on the dimensions of the problem, the just the sheer challenge that we face in dealing with climate change, and then ultimately focus on the question of who should bear the major burden of carrying out adaptation to try to mitigate um, the the buildup of greenhouse gases in the atmosphere. Now, of course, the obvious answer is everybody should bear their responsibility. Everyone should. We're going to need every country, every citizen, every company to step up and make contributions. But nevertheless, when countries do come together to negotiate, they're quite aware, and they're for political leaders, their citizens are aware of the issue of, well, how much am I going to need to pony up? How much adjustment, how much change will I need to carry out compared to other countries? No country wants to do more than their fair share, but that raises the question of what is fair? What is the fair allocation of burden or costs? So we'll get around to that in a little bit, but let's begin with a couple slides that illustrate that in the United States, at least, the attitudes about climate change have begun to change quite dramatically. Um, for instance, if you look at when you ask Americans what should be the top priority for the president and the Congress, um, not unexpectedly, economic growth and jobs have traditionally been cited as among the highest priorities. And you can see that global warming, or more broadly, environmental protection, were distant down the list quite. If we look at, for instance, between the period of 2008 to about 2016, of course, that was a period of the financial crisis and its aftermath, and people were focused on the economy, on jobs. They weren't focused on climate change. But look what's happened in recent years. The priority that people give to environmental protection and to climate change has risen. And in 2020, actually, climate change was cited by slightly more people as the highest priority over jobs, even. Now, that was early in the year before the pandemic set in, but it still shows a trend line where Americans are taking this issue much more seriously than they have in the past. Um, However, one of the unsettling realities is that the issue of climate change has always uh, been one that brings up partisan differences, but those partisan differences have grown enormously even in recent years. So if we look back at, you can see the gray line in the middle is sort of um, the overall trend in numbers of people, percentage of Americans who give high priority to global warming, or later questions use the term climate change. Um, but you can see that the blue line, more Democrats than Republicans thought that climate change should be considered a top priority. Um, but the gap was significant, but it was much narrower in the past than it has become recently. Now for if you're a Democrat, um, more than 75% say that climate change it should be a top priority, whereas less than 25% of Republicans. Um, we can see similar kinds of disparities in responses, for instance, to the current pandemic. Frankly, there is a big difference across parties in how much credibility that people give to scientific authority. Democrats are much more likely to believe scientists and to think that we should respond to scientific warnings and information. Republicans are much less trusting of scientists and much more dismissive of climate change. Now, that doesn't mean all Republicans, obviously. Um, and if you look at the trend lines here, you see that actually Republicans are a little bit more more willing to give priority to global warming than they were, say, in 2010. The biggest change has been among the Democrats. Republicans, that line, that red line down there, is fairly steady, but Democrats have become much more concerned about climate change. So once an issue turns partisan, it becomes much more difficult to get action because we have a political system in which minorities are able to block policy change. If you look, for instance, at the filibuster in the Senate, um, so unless you're able to win over at least some folks on the other side of the aisle, then it's very difficult to get major legislation to deal with a problem like climate change. Well, let's look at the problem itself now. Um, this shows the CO2 levels, which have changed over long periods of time. This looks at a period of 400,000 years. There are variations over time in the level of CO2 in the carbon dioxide, which is a greenhouse gas, and a greenhouse gas is, as we know, they allow sunlight comes through the atmosphere, hits the earth. But if there's a buildup of greenhouse gases, their effect is to trap that heat and prevent it from going back out into space, and therefore the earth heats up. It's called greenhouse. They're called greenhouse gases because it works like a greenhouse, where you have um, the sun, even in cold of winter, the sun comes through um, the window panes in a greenhouse, and it hits the whatever's inside, and that creates heat and radiation. But instead of filtering back up into the atmosphere, rising, it's trapped by the panes of glass. And so even in the winter, a greenhouse can be quite warm. Well, that's kind of what's happening to our Earth right now. Um, Again, there have been variations over time, but if you look at the level of CO2 in the atmosphere today, over 400 parts per million, um, compared to even at the very height 300,000 years ago, it was 300 parts per million, so much higher. And we know this from looking at ice core samples, by the way. Let's look at this video, which not video, but this web page, which shows us a variety of climate change related measures and just how out of how much our current reality has shifted from historical patterns. So if you look at the upper left-hand corner, you'll see those are CO2 levels. As in the previous slide, you see a big spike in recent years. The next one to the right is methane, which is even much more powerful, maybe 1,000 times more powerful greenhouse gas than carbon dioxide. And you'll see methane levels also have spiked. Nitrous oxide, another greenhouse gas, also spiked. And because those gases, greenhouse gases, have the concentration has risen, we also see then the temperatures rising. That's in the lower left-hand corner. Look at those temperatures going up. We've actually passed through a relatively cool period in the human history since around 1500 or so, uh, but it's really warmed in the last couple centuries. And then you get to the sea level rise, um, really shocking increase in the sea levels, and they're going to rise much further in the future. And then on the lower right hand side, oxygen concentrations in the atmosphere, which vary with seasons, of course, but the overall trend line is really quite dramatic. So um, those are some indicators that show that global um, warming, climate change is real. It's occurring. It's moving quite rapidly. In fact, every major report that's been done by the International Panel on Climate Change, which is a group of scientists that have thousands that basically look at all the research and try to summarize it. They've at each point they've tried to develop projections of how fast greenhouse gases will build up, and then how much response we'll get in terms of temperature and sea rise level, ice melting, etc. And with each report, they found that their past projections were too cautious, too conservative, that the actual reality was much worse than they had previously realized. So, if you look at the Greenland, for instance, at the amount of ice that's being lost there, it's much faster melt than we had really anticipated. Now, this is a chart that shows three different scenarios, projections about depending upon how quickly or whether we bring down CO2 emissions. Um, and you can see that basically a business as the current projections, if we don't make any adjustments, are at the top, and what it shows is that the brown dot along that top dotted line, it shows the year, which is coming up within the next decade, when the temperature rise will exceed 1.5 degrees Celsius over pre-industrial levels. And then around 2045 or so, you get to a temperature rise of 2 degrees Celsius over pre-industrial. And then uh, around 2060, it jumps up to 2.5 degrees, and then around 2075, we get up to 3 degrees over Celsius. If we don't do anything right now, we're projected by the end of the century to go over 4.4 degrees warming. Now, that doesn't sound a lot, but as we're going to see in a moment, the actual consequences for the Earth and for humanity are really astounding. So that's I won't say it's even the worst case scenario, but it's a bad case scenario. We did, in 2014, the countries signed the Paris Accords, in which each country made commitments to what it would do to fight climate change and how much it would bring down greenhouse gas emissions. And if you took all those pledges, they would basically get us halfway to the amount of reductions that will be needed in order for us to keep the temperature from rising more than 2.2 degrees Celsius. Again, halfway to the cuts needed to avoid going over 2 degrees Celsius. Um, Now, the middle projection actually takes those Paris cuts. It assumes that there are later commitments that countries go beyond what they had said they would do at Paris. Now, in reality, of course, very few countries are actually keeping up with the commitments they made 6 years ago, and the United States is actually withdrawn from the Paris Accords. So that middle projection is based upon some pretty optimistic assumptions that countries will jump back on their catch up with their previous commitments and then do much more than that. So if we took that as our expectation, then sometime in the next, by 2030 or so, we'd basically level out in carbon emissions, and then sometime around mid-century begin a gradual reduction, and we would reduce carbon emissions to a fairly low level by the end of the century. Now, if that's the case, then you can see that we don't ever reach 3.3 degrees Celsius rise. Instead, the peak is going to be around 2060 at 2.5 degrees Celsius rise. So we're not able to actually keep it from down to 2.2 degrees with this scenario. The only way that we keep it below 2 degrees is through radical reductions, and that means that we make a major heroic major effort that leads to the peaking of CO2 emissions now, this year, followed by really dramatic reductions until 2030, and then a slightly less, the reductions from then till the end of the century are at a slightly less steep downward trajectory, so that by the end of the century, we actually begin negative emissions, so that we have some mechanism to suck up more carbon dioxide than we're emitting. This kind of scenario would require an enormous policy changes and new technologies that we don't even have at present. One of probably the simplest and easiest and most effective policy change would be to put an enormously high tax on the use of on carbon emissions, so as to create an economic incentive for both producers and users of energy to shift away from oil and gas and coal into other ways of either conservation or using solar, wind, nuclear, hydro, and other kinds, wave energy or other kinds of energy that are non-fossil fuel burning. So if we were to do that, then we would limit the amount of warming to levels that were probably manageable. However, notice that I'll leave you to read all this, but basically, even at 2 degrees warming, the impact will be dramatic. Melting of ice sheets will pass a tipping point of collapse. Dozens of the world's major cities will be flooded. Global GDP will be cut by 13%. 400 million more people will suffer from water scarcity. Heat waves will kill thousands each summer. In India, many cities would be unlivably hot, 32 times as many extreme heat waves, each lasting 5 times as long and exposing 93 times more people. That's if we're successful in reaching the goal that was set out in the Paris Accords. So now the Paris Accords did say that 2 degrees was the goal, but it also said that um, we should try to do better than that at 1.5 degrees, but no scientist believes we can keep it to 1.5 at this point. Well, what if temperatures rose 3 degrees? And this is probably a fairly realistic scenario at this point, given the very limited movement that we've made so far. We haven't even peaked emissions yet. We're still going up. We haven't started reducing. Well, in this case, Southern Europe would be in a permanent drought. The average drought in Central America would last 19 months, and the Caribbean 21 months, 60 months in 5 years in Africa. The areas burned each year by wildfires would double in the Mediterranean, sextuple in the U.S. The sea level rise would swallow cities from Miami Beach to Jakarta. Damages just from river flooding would grow 30-fold in Bangladesh, 20-fold in India, and 60-fold in the United Kingdom. What if business as usual pertained and we allowed temperatures to rise by 4 degrees Celsius? 8 million cases of dengue fever each year in Latin America alone. Global grain yields would fall by as much as 50%. Food crises, 30% smaller global economy, and a growing amount of conflict and warfare as climate produces massive refugee flows across borders and resource scarcities. All right, so we've got to do something. The question is, how do we do it? And we're going to focus here on as well who does most of the lifting on reducing emissions and dealing with climate change. And by the way, since we know that a significant amount of warming has already taken place and is already built in because of past emissions and expected future emissions, no matter what we do, then we're going to have to put a lot of money, huge amount of money, in adapting to climate change. For instance, building seawalls or relocating people inland away from coastal cities. Dealing with the effects of the expansion of malaria, for instance, into temperate zones or other kinds of effects. So there are going to be an enormous and growing amount of costs just in adapting. On top of that are the costs that will go into mitigation, such as shifting to a fully electric car fleet or dismantling the whole fossil fuel infrastructure to replace it with something better. Now, let's look at how the CO2 emissions are spread per person. If we just look at which countries have the highest per capita emissions, well, the United States is way ahead of anybody else. The U.S. Americans consume a lot more than other countries, and we consume a relatively energy-intensive mix of goods and services. And so we're basically almost twice as our level of emissions per person is basically more than twice that of Europe or China, and then many more times that of developing countries. The global average is 4.6. The U.S., as you can see, is close to 18 tons per person. So there, it's the U.S., the Middle East, which is an energy-rich region. Europe and China are the big emitters in per capita terms. What about if we look historically, right? Because we didn't just start emitting yesterday. We've been putting these fossil fuel emissions into the atmosphere since the beginning of the Industrial Revolution, which, as I mentioned earlier in the semester, was fueled by the use of fossil fuels. So here, if we look back to the late 19th century up to near the present, we see that the green and blue shaded areas show the proportion of the global total emissions accounted for at different historical periods by the United States and Europe. And you can see that up until just the last few decades, the vast majority of the CO2 emissions put in the atmosphere came from those two locations. The rest of the world were basically bit players. Now we see China rising very rapidly toward the end. If we put this out a little bit, we'd see that China has risen now to become a bigger emitter than the U.S. Has, or Europe. You can see the all others, that's the rest of the world beyond the countries that are listed to the right. So developing world has also, their emissions have risen very rapidly from a very low level. And you can see that the share accounted for by Europe has declined quite a bit. So here, historically, the U.S. and Europe accounted for the lion's share of the CO2 emitted since the beginning of the industrial age. This looks at per capita emissions, and you notice here we didn't include Canada earlier in the previous chart we looked at on per capita emissions, but Canada being again an energy intensive country in a cold weather climate, so Canada's even more energy uses more energy per capita than even the U.S. Russia is also very high, and then you can see other countries below that. What if we look at energy intensity? That looks not at energy emissions per person, but per dollar of GDP, right? And so countries that have bigger, higher incomes will see how, well, it's not by the size of your income, it's by how energy intensive your consumption is, right? So if you look here, you see that Indonesia, for instance, their energy emissions per person, per GDP, for each unit of GDP, each dollar produced are very high. The China is actually higher than the U.S., Canada, Russia are at the top. The U.S. is a bit below that. So we're very high on per capita basis, but we're not quite so high on a per GDP basis. Now, one reason is because the Americans have shifted their consumption patterns toward a more service-oriented economy. And so that is less energy intensive than a consumption mix that includes lots of produced manufactured goods. If we look at consumption-based emissions, this is looking at, let me go back. This is actually looking at what you produce, right? So GDP, this looks at the income, energy emissions per dollar of production. This looks at consumption. The reason there's a difference is that a lot of manufacturing factories moved from the U.S. and Europe to China and other countries. And so, for instance, China, it produces more. If we look at its energy consumption intensity per production, it's higher than its consumption, because a lot of what China produces is actually consumed in Europe or Japan or the United States. So the fact that the factory used to be in Indiana and now it's in Guangdong means that, but the goods are still being consumed by Americans. Well, who should be responsible for that that carbon output? Americans because we consume the good, or China because that's where the goods produced. So to some degree, China's, if we look at production, China's output is artificially high because a lot of its goods are actually sold abroad. Now this chart kind of pulls together, it looks at the historical cumulative emissions on the left side, and it breaks that according to the proportion of the global total accounted for by different countries. China in the kind of orange, US in the green, EU in the blue, and India in the purple, and then all other countries in the gray. So it looks at the proportion of the cumulative total accounted for by different countries or regions, and then we just made this distinction between energy emissions measured by production versus consumption. And here we show in 2014, we show the breakdown, and then by population, that's per capita, and then by GDP. So we can see that, by some measures, China, if you look at historical or cumulative, or if you even look at GDP, if we look at market exchange rates, which is one way of measuring GDP, then China, its responsibilities would be lower. If we look at China's share measured by production, then China's share is much higher. The U.S. share is much lower if we look at, just per capita, but it's much higher if we look at the historical or if we look at by market exchange rate GDP. So depending upon which measure you use, you would allocate the burden of adjusting to climate change differently. Now, to illustrate why this is such an important issue, let's look at a scenario represented by the dark line here, where emissions have peaked around 2020 and started downward, that the world really gets serious about climate change, begins cutting, and it cuts at a rate that would give us a 2/3 chance of keeping the total warming to 2 degrees Celsius. All right? So that's, in order to do that, we'd have to cut at the rate of decline that's represented by that dark line. Now, based upon our current projections, we can see here going out to 2030, the amount of emissions that we expect the United States to produce, the EU, India, and China. Those 4 countries or regions together would take up all of the emissions that we could allow ourselves, and actually a bit more, and still stay on that stay on the trajectory necessary to keep the world from rising more than 2 degrees Celsius. So if the rest of the world would have to not emit any carbon CO2 emissions at all, that China, India, EU, and the US would their expected emissions would take up all the emissions that we could allow ourselves, so to speak. So obviously the rest of the world won't agree to that, and therefore the only way for us to to keep to a commitment to reduce emissions sufficient to keep a 2-degree warming would be for China, India, EU, United States to make major reductions in their own emissions to kind of free up the space for other countries who, after all, are developing countries who want to improve their own standard of living and have every right to do so, to give them the space, so to speak, to emit, even though we would hopefully expect them to also begin reducing their emissions. Now you can see that the EU and the United States, our emissions are expected to decline. India's will be growing. China will be growing, and therefore it's really essential that China make major reductions in its emissions. This is another way of looking at what's called a carbon budget. So if a carbon budget is, okay, how much carbon in the next, 40, next 30 years, how much carbon could we allow ourselves to burn and still stay on a 2 degrees Celsius warming trajectory, right? That we're not going to allow it to rise more than 2 degrees. How much carbon could we allow ourselves to burn? Well, let's take the period from 2000 to 2050. In order to the amount that we could allow ourselves to burn without exceeding 2 degrees would be that top red line, okay? And you can see over to the left-hand side, it shows that just in the first decade between 2000 and 2011, we already burnt the black circle there, and that would mean that the amount we could allow ourselves to burn from 2011 to 2050 would be what remains in the gray circle at the lower left-hand side. Now, the big circles, coal, oil, and gas, and their cumulative total, that represents the amount of global fossil fuel reserves we actually have available to burn, right? That we already know, we've explored, we know where those reserves are, and in fact, energy companies have already built into their business plans to exploit and burn those fuels. Well, what's clear is that if we were to allow fossil fuel companies to exploit and burn all of the fossil fuels that they've already identified, much less the fossil fuels that they might identify in the future through future exploration for more oil and gas and coal, if we allowed that those companies to basically burn whatever they want, we would blow way past any carbon budget that would be necessary in order to keep us at 2 degrees or below. What that means is that the vast majority of the fossil fuels that we currently have in reserve need to stay under the ground, and that the companies that have built those, exploiting those reserves into their business plans, they have to be dissuaded in some way through regulation, through changes in prices, from actually doing so. Now, one of the things that has happened is that insurance companies have basically said, well, we have to, your business plans, the survival of your company depends upon implementing a business plan that would, if it were carried out, destroy the planet. And therefore, that's not going to happen, which means that your business is not going to perform and may even go under once governments step in to intervene and to prevent your company from burning all those fossil fuels. As a result, insurance companies have begun raising insurance rates on firms. Also, stockholders, like big pension firms, have been saying, our investment in Exxon Mobil is based upon their projections of revenues and profits, which themselves, those projections, are unrealistic because they assume that they are not going to be forced to stop doing business the way they've done in the past. So they've stock prices have started to decline as shareholders realize that these are not going to be good investments going forward. Now, one of the challenges is that the countries that are contributing most to global warming are not the countries who are going to suffer the most. In the upper half of this map, these two maps, you can see that the highest emissions countries are those that, by per capita, are those in the sort of orangish to reddish colors. And those, with bluer colors are low emission countries. Well, obviously, with the exception of Australia, most of the high emission countries are in the northern hemisphere. Now, on the other hand, if you look at the countries that will be most impacted by climate change and most vulnerable to the negative effects, again, we put high vulnerability countries in red and lower vulnerability in blue. We see that the highest vulnerable countries are in the southern hemisphere and the lowest vulnerability is in the northern hemisphere. This is not good from the perspective of incentivizing those who are able and need to make the biggest cuts to do so, because they're not the ones who will suffer the most. This shows which countries are most vulnerable to sea level rise. With 2 degrees warming, we'd expect a 6-meter sea level rise. Well, many cities on the coastlines will be underwater at 6 meters rise. You can think about how much that would be. It shows in the United States, for instance, we're sort of in the middle. 12 to 24 million people currently live in areas that will be below water, below the sea, the under the waves, basically, by the end of the century at current projections. China is the most affected in terms of just sheer numbers of people, between 40 and it looks like about 66 million people will have to be relocated because they live in coastal areas that will be underwater. So, raises a lot of questions about, who bears the cost of adjustment. Should it be countries that are the least efficient in energy use? Because after all, if that would be the low-hanging fruit. If you're inefficient and there are more efficient ways to use energy, then that's economically a sensible move to make, and it's the cheapest way to make progress. Or should it be countries that have contributed the most to the cumulative greenhouse gases? Should we take history into account? Say if you put most of the emissions there, then you should make the biggest efforts to reduce emissions now. Or should it be countries that currently contribute most to greenhouse gas emissions? Should we say, well, forget what happened in the past. Right now, we have to focus on reductions, and it's the countries that emit the most that are going to have to make the biggest adjustments. Or should it be countries that have the highest per capita CO2 emissions. So we look at the relative burden, the relative contribution, rather than just big countries that have big populations have to bear burden just because they're big, or should it be, well, countries that, whatever their size, are emitting a lot per person, they should have to carry the biggest burden. Or finally, should it be countries that have the greatest ability to afford the investments needed to cut emissions? In other words, the richest countries should be the ones because they have the resources, they have the economic ability to carry out massive investments that are needed to carry out bring us to a post-fossil fuel era. So we'll talk about this in class a little bit and see what your thoughts are. But these are some of the real life, trade-offs and complexities that policymakers and negotiators deal with in climate negotiations. All right, that's the end. Thanks.